Hello folks and welcome back. Today we're going to talk a bit about circuits. Now circuits, you have to learn 3 of them for your A-level exam. We are learning about a half adder, a full adder and a flip-flop. Okay, so let's get started. The first circuit we learn about is the half adder. So a half adder is a simple circuit. If A and B are So if A is 1 and B is 0, so you've got 1 positive charge, then this being a XOR gate, it will allow the number to go through to the S. But if A is 1 and B is 0, well, and they also come down here to an AND gate. A1, B0, the AND gate will say no, go away. And equally here, if B is 1 and A is 0, again the XOR gate will pass out a function, that'll be 1, and the second function, the AND gate, will say nope, not allowed. But if both of these are 1, so 1 and 1, then the XOR gate will say no, not allowed, but the C gate will say yes, and they'll output a 1 here. So 1 and 0 will equal 1, 1 and 1 will be in the C, or the carry 1. Now this, guys, is exactly the way you do binary addition. This is how you would add 2 bits in binary. Now, the only problem though is that to do a binary addition, you need to put the carry into the next one. So if we had 1 here, in the next calculation, we need to add it to the next calculation. And that can't be done in a half adder, but it can be done in a full half adder. We have learnt about and this is a half adder which is used to do simple addition of bits on your computer. Thank you for watching, and I will talk to you again soon. Adios. Full adder. Now this, guys, is the full adder. So exactly the same process as last time. You've got a XOR gate and you've got an AND gate running off them. But there's also the C in, or the carry from the last calculation, is sitting right here. Okay, so in the XOR gate, it will say if there is only a 1 in there, then that will go through there and it should come through here. But if there's a carry, well, in that case, there's 2 going there, and that's not allowed. So it goes to an AND gate, and then again, it will produce a carry. Okay, so this is how, using circuits, using Boolean logic, you do binary addition. So to add up binary numbers, an 8-bit binary number, you would need 8 of these circuits for each number you did. Say you had to add up 64-bit binary addition, you would be doing 64 of these circuits for every calculation you did. So as you can imagine, guys, those millions of transistors inside of the latest CPUs suddenly get used up very, very, very quickly. Okay, so guys, so far we have learned about the full adder. Finally, we get to forget adding, which was a full adder, which is used to, in a chain, to calculate binary addition. We get to move on to our flip-flop. Now, a flip-flop circuit is useful for one reason. Firstly, we have 2 inputs, S and R, here and here. And here, click, well, that is how fast your CPU is running. So many times a second, about 3,000 or 4,000, your computer will send out an electronic pulse to all its circuits, and that's what comes through the click. Okay, now the way this circuit works is data passes into it, and if they're both positive, data is kept inside the circuit for a single pulse of the click. That means data is stored for as long as there is power entering the circuit. What sort of storage stores data? while there is power to the computer, but then loses it as soon as power is turned off? Yep, that's right. This is a way of storing a single byte in RAM. Now, if you imagine, guys, you had to store a single bit in RAM, sorry. Imagine you had, say, 8 gigabytes of space in your RAM. Imagine how many of these circuits are sitting inside your RAM chip. That's a ridiculous number of flip-flop circuits. Okay, so this is a flip-flop. It's used to store memory in RAM.